So it was in the mid-'80s. I was working on nuclear fusion at that time. This is how do we take fusion in the laboratory to get power. It's going to be the power source of the future. And I worked on it for 10 years of my career, and I was convinced, yes, it is going to be the power source of the future, and always will be. Which means I probably won't be around to see it. Not because it couldn't be done, it's because material science questions were just too difficult, and still no one's needing an assignment. But I was working on when this epidemic came out, this story about the gay epidemic, and all we knew it was 100% infectious. I'm sorry, no, it was 100% deadly, mortality. Everyone that got it eventually died. And it was spreading as a sexually transmitted disease. Now, what else we knew was that other sexually transmitted diseases like syphilis and gonorrhea, and there was a herpes 2 epidemic going on there, they all seemed to infect about a third of the population before they topped out if there wasn't treatment. So when the drugs came in for syphilis, I think it was 32% of the men were infected. At that time, 28% of the men were infected with herpes 2. Mostly these were asymptomatic, but they were still infected. So we thought, wait, if HIV, or we didn't know it was HIV at that time, if this new epidemic spreads that way, we could have looked at a third of the planet dead or dying in the next 20 to 30 years. And so literally, like Los Alamos exists for one reason, to give some scientific guidance on problems of national importance. A team of about 12 of us stopped everything we were doing and said there's no more important problem for us to work on to see if we can understand where this epidemic is going and what we can do to help stop it. So that's when we started the International HIV/AIDS database. I started on understanding how the epidemic was spreading. A colleague of mine, Alan Perlson, started understanding what the HIV virus does inside the immune system. We had a public health worker who started working on how we get people to use more prophylactic treatment, et cetera, and literally lived this story for the next about 10 years. This was, these were 15-hour days. And we uncovered, I think we did uncover some things that were useful in understanding where it's spreading, how to stop it. Now, we were extremely fortunate that it's only about 1% as infectious as syphilis and gonorrhea. So they're about 100 times more infectious than HIV/AIDS. So our horror story of a third of this country being dead or dying, it hasn't happened. But there are parts in South Africa, Botswana, where they do have 25% of the population, not high risk, but the average population, like us in the room, are infected. And they will be dead and dying. They are dying now, and they, without drugs, on an average, it takes about 8 to 10 years before someone dies of the disease. And we don't fully understand why it's spreading so rapidly there heterosexually, and it's not here. So after the break, I'll go on kind of through what we've done with HIV/AIDS, and then I'll end talking about what the current models are, the state-of-the-art models that we use for the CDC today when a new epidemic comes. That's a good stopping point.